Hello students, welcome back. If you have ever noticed that the most successful projects are often the ones that dynamically adapt rather than stick rigidly to an initial plan. This lecture is going to show you the exact strategic tool behind that agility. We are going to look at how agile leaders understand their stakeholders and the relationship of the stakeholders with the technical landscape, evaluate uncertainty or yuka environment, and set their agile teams up for predictable success from day one. To do that, we use one of the most powerful strategic tools in the agile ecosystem, the Stacey Matrix, developed by Ralph Stacey and adopted in early 2000s for agile projects. This model gives us a clear framework to measure and visualize project uncertainty before we choose our delivery method. Let's understand how this matrix visualize your project space. The beauty of the Stacey matrix is that it strips away all the surface level noise of a project and focuses heavily on just two critical axes, technical certainty and stakeholder alignment. Let's break down both dimensions using a massive real world example, a global logistic company updating its operations. On the x-axis or the horizontal axis, we map out the technical certainty, that is the how of your project. Specifically, how well we understand the technology, the tools, and the steps required to build the solution. It answers the fundamental question: do we actually know how to do this? On the left hand side, it is close to certainty. This is your predictable zone. If our logistic company is buying 50 standard barcode scanners for a brand new warehouse, the technical certainty is incredibly high. We have done it 100 times before. There are clear installation manuals, standard APIs, and predictable outcomes. Cause and effect are obvious. On the right hand side, we have the far from certainty. As you move to the right, you enter uncharted territory. Suppose the executives decide that instead of manual scanning, they want to deploy autonomous drones equipped with experimental machine learning algorithms to scan moving pallets in real time. We have never done this. The technology is brand new. The physical environment introduces massive variables and the technical certainty plummets towards minimal. On the y-axis or the vertical axis is the stakeholder agreement. It represents the human and political dimension of your project. It answers one very simple and important question: does everyone agree on what we are actually building and why? On the lower section is close to that agreement. This means absolute agreement. Every stakeholder, executive, and team member shares the exact same vision. If the goal is simply to reduce package processing time by 10% using our existing software, everyone signs off instantly. The expectations are clear, cohesive, and unified. On the top of the y-axis, it is far from agreement. As you move up the y-axis, political friction takes over. Imagine the logistic company decides to consolidate three regional distribution hubs into one centralized mega facility. Suddenly, the regional managers are fighting to protect their local jobs. The finance team demands a strict budget cut, and the operation team insists on a massive space setup. You have high conflict, competing priorities, and minimal agreement. As an agile project manager, you have to take care of these agreements. Now, as an agile project manager, you might ask why mapping both dimensions changes everything. Here is the ultimate takeaway that most traditional project managers miss. A project can become highly complex even if the technology is completely simple. Let's say you have a project with 100% technical certainty but zero stakeholder alignment. Your project is not so simple. It is sitting high up on the Stacey matrix in a politically charged environment where a rigid linear project plan will fail instantly. Conversely, you could have total stakeholder alignment. But if the technology is experimental, a fixed blueprint will cause a major crash. So whenever you kick off a new initiative or a new release or a new feature development, your first job is to pause and plot your coordinates on the Stacey matrix. Ask yourself these two simple questions. Where do we sit on the how line or the x-axis? Where do we sit on the what line or the y-axis? In our next lecture, we are going to explore the four unique zones created by these two axes: simple, complicated, complex, and chaotic. And let's look at how you can accurately classify any real world project scenario. See you in the next lecture.